That is, I'll blend there to becoming what we can use indices to solve. So since after that time, law of indices can be introduced. So to doing that, so we look for the index term. What are the index term we have? We have exactly what I have here is what I have here. Abi. So once it's just like this exactly, no problem. But tí ó bá ti rí bẹ́ẹ̀, there will be need for us to do what? Some adjustment. So since the index number I have here is the same thing as what I have here, Abi, then I can give it a name, right? So that we can now say that what? Let what? R and Roger R is equal to what? 3 raised to power x. So meaning that anywhere I see 3 raised to power x, I will identify it as what? As R. I hope everybody did the assignment. I'm still coming to come and to check your notes. I'm coming. So we have R squared, Abi, plus 2 into R, or 2R minus 3 is equal to what? 0. That is R squared plus 2R minus 3 is what? 0. Now what now happen? You can see this thing look quadratic, right? So as a result, we are going to apply what you understand about quadratic equation. There are 3 methods you can use in dealing with this thing. You can use a factorization, you can use a completing the square method, you as well can use what? Almighty formula. So depends on you. Which one do you want to use? But the shortest we can apply is what? The factorization method. Factorization left. So in that situation, coefficient of R squared multiplied by the last number, that is 3, Abi. Now, what factor of 3 can give us plus 2? Now, when we say factor of 3, what times what can give you 3? Only 1 times 3 can give us 3, Abi. Now, how can I combine these two numbers and arrive at plus 2? How can we do that? So, it's only when we subtract 1 from 3, right? So, in that case, I will write it as R squared minus R plus 3R. And then they change here, no. 3R can come first, minus R comes last. Minus 3 is equal to what? 0. Then, between this and this and this, Abi, we can see R is common. So we say R into R minus 1. Hope this area is clear. Is it clear? For some of you that have not taught factorization, quadratic equation as a topic, that was the reason I taught you what? The almighty formula. So if you don't understand this now, you don't have problem. Apply your almighty formula. What matters to us is value of R. Is it clear? So, kilo common be by 3, Abi. We say 3 into R minus 1 is equal to 0. But in order not to waste our time, is the reason we are using factorization method. So it's clear. So to conclude this thing, we say R minus 1, R plus 3, you can see yourself, is equal to what? 0. So what is the meaning of this? This thing has meaning, but I'm not going there. But in the short form, let's simply say R minus 1 is equal to 0 or R plus 3 is equal to 0. When we go to quadratic equation proper, I will tell you how they come with saying that what? R minus 1 is 0 or R plus 3 is equal to what? 0. Now, we can say R is equal to 1 or R is equal to what? Minus 3. But remember, we have to solve this equation. And in this equation, the only letter present there is what we are supposed to find, right? So, but what we have here is just R. What is the work of this R? R here enables us to be able to deal with this thing, right? From this junction now, we are now going to go into area where R was introduced into this stuff. When do we introduce R into what we have here? It was at this junction, Abi. So you now go back into that place and say that R is equal to 3 raised to power x in a standard manner, right? Usually say that word, but R is equal to 3 raised to power x. Can I continue? Now that r is equal to 3 raised to power x, we know r has two values, right? So that means I can say 1 is equal to 3 raised to power x. Or I can say that what? Minus 3 is equal to 3 raised to power what? X. So you can see it looks somehow indica now, right? But to join indices. So now we can apply our laws of indices. Is it clear? Now, what sense can you make from this? We can say 3 raised to power 0 is 3 raised to power x, or minus 3 raised to power 1 is equal to 3 raised to power x. Are you with me? Now, what will happen? 3 will cancel 3. We say here x is equal to 0, or you see this area here, we cancel it like this. It is not possible. You know why? You know why? Because base has to fit perfectly like this one. What my base is here is what my base must be here. Is it clear? Once sign comes in to differentiate them, then it shows this is not possible. There's no possibility of dealing with this. Is it clear? Like I used this my table the other time. So it's clear. This is a negative 3. Negative 3 is not the same thing as plus 3, right? So the two numbers are not the same. Since the base are not the same, there is no point in talking about this at all. Is it clear? So, it will be rara. So no point in saying or. So therefore, value of this solution to this thing simply means x is equal to what? X is 0. Is that what we get? Let's check our notes. Oh yeah, where is it? Let me see. What are your answers?
0
or 1, but you can, because in this area, if you try to force yourself and do it, come and see. Let's assume we force it only. Minus 3 raised to power 1 minus 3 raised to power 1 is equal to 3 raised to power x. First thing is we want this to cut this. How do you do the cutting? How do you cut it? It is not just possible. Okay, you want to introduce bracket. Oh yeah, let's form something. Oh yeah, minus, you now say 3 raised to power 1 is equal to 3 raised to power. Let's assume we want to cut it, Abi. All right. Oh yeah, this 3 cancel this 3. What of this minus 1 here? How do you adjust that? Because when we are cancelling, we don't want to see anything about the base again. Is it clear? Okay. How do I cancel this thing? That something related to that base will not still be here. Is it clear? It's like you have malaria and you are given an anti-malaria drug. What do you expect when you use the anti-malaria drug? The expectation is that the drug should be able to do what? To kill that malaria totally. Is it clear? You now use the drug. Something related to that malaria is still present in your body. What will happen to you? Will you be okay? You will still not be. We don't want to see any trace of that base again. Since this negative sign is still leaving the trace of this base, then it shows we should not use it at all. Do you get it? You should not look at this area at all. No solution can be gotten from this side. Our solution can only come from where? Only from here. Why? This is the only one following that is obeying instruction. Eléyìí ò ready láti tẹ̀lé instruction. Is it clear? Ká ló ready láti tẹ̀lé instruction ni this base will totally cancel the base we have here. Ṣáàrin yẹn clear? So I have to tell you so that when next you have question of this type, this is the first time we're having question like this. So in case you miss it, you are not at fault. Do you get that? So that's the solution. Oh yeah, how about this next one? Kia. Okay. All right, number 2. I think I gave it to assignment. 3. Okay, I said the third one. Can I rub this? Okay. So the third one depends. I do that one. I told you it is optional. If you want, do it. If you want, don't attempt it. Okay, yeah. What's the next question? X raised to power 2. Okay, 2, okay, fraction. 2 over 3. 5, 5x, or 5 raised to power. 5x raised to power 1 over 3 plus 6 is equal to 0. I cannot hear you. Let me have your notes. Okay, don't worry, I have it here. Okay, 5 raised to power, what do you call it? Do I have it here? Okay, 5 raised to, okay, x raised to power 2 over 3 minus, you see, minus is what I have here, not plus. Some people can write. Okay, 5 raised to power, 5x raised to power 1 over 3 plus 6 is equal to 0, and that is it now. Okay, in this one, no bracket. Yes, thank you. Okay, no bracket is there. All right, so what do we do? What do we do? Now, you can see between our index number, once we have negative sign or positive sign, it shows laws of indices cannot be applied direct. So this is called, okay, don't worry, I need not go into that area. So most of our law of indices cannot be applied directly. Something has to be done first before we can what? Apply a law of what? Of indices. And I said that thing is a form of what? A form of trick, right? Now, what we want to happen is we are looking for a situation whereby the index term, this is an index term, this is an index term. We want to create a situation whereby they look exactly the same thing, right? By the way, index here, this is an index number, this is an index number. Same base, the power this one carries, I want this one to carry the same power. Is it clear? And now, which of the two index number has the minimum base? Sorry, the minimum power. This one has the minimum power, Abi. So the one having the complex power will have to be what? Adjusted. I think you're clear. So one is x raised to power 1 over 3. The other one is x raised to power 2 over 3. We don't have issue with the coefficients. That one is very easy to deal with, Abi. Now we have x raised to power 1 over 3, we have x raised to power 2 over 3. So this is simpler compared to this, Abi. How can I adjust this to have something like this? Right? If Tebaya getting follow, then it shows one of the things we can do is to say that what? X raised to power 1 over 3 times 2. Abi, what is 1 over 3 times 2? 1 over 3 times 2. Is it not going to be 2 over 3, which is what we need? Do you get that? Do you get it? It's not clear to you, Mr. Fele. Do you get it? So that means I can write this thing as x raised to power 1 over 3, 2 outside like this. 2 outside like this. Abi? These 2 can as well be written as, I have it here, 2 over 1. Oh yes, Lamia. Now we now say minus 5x raised to power 1 over 3 plus 6 is equal to 0. Normally, when dealing with indices, I have told you, primary laws we should use is what? Law 1 or law 2. Is it clear? Other law comes in when we have an abnormal index number, or what we have as the power of what? Of 0, or it has fractional power. Is it clear? Those ones are later affairs, but basically, ìpìnlẹ̀ is you use either law 1 or law 2. When do we use law 1? If what we use to combine them is times. And if what we use them to combine, what we use to combine them is division. Mr. Man, you are sleeping. If what we use to combine them is what? Is division, Abi. And that's when we make use of what? Our second law. Shaking, continue. Can I continue? But the situation we have now is, in between these two index numbers, we're having minus, right? Once you have minus, no law can be applied directly. Something has to be done before we can now apply the law. I hope that is clear. And that's the reason why we have to go this way. Checking the show. Then remember, in this place, what we want to do is the index part of this question. We want to create a situation whereby they look perfectly the same way, so that we can give to them what? A special naming. Kò clear? Ṣó yé? Aunty Rodia, is it clear? So ìdí nìyẹn tá a fi ṣe gbogbo eléyìí. So in this situation, you must make some adjustment. It's like you cook food at home, and when you ask somebody, help me to taste it, and you are told, kò dùn, kò tíì dùn, kò sí kinní kan bẹ̀. What do you now do? You now apply that thing into your soup. Àbí irú ohun tó ṣe yẹn gangan is exactly what we are introducing here. Is it clear? Is it clear? So so that's the reason I always tell you that what? Everything is what? Everything you are doing is mathematics. Can you see that? Oh, on your sister's wedding day, you have dressed up. Now, mommy, am I fine? Mommy now told you that, no. Tún ṣì lọ ṣe báyìí, tún ṣì lọ ṣe báyìí. That thing your mommy told you is what? It is mathematics concept your mommy is applying. So, you can see, there's nothing here, real line. Or is it clear? Now that we have this and this looking alike, Abby, what can we do? What can we do? You know, I've not forgotten, I know, my son. Now, what can we do? We are now going to do what? Introduce the name. We now say that what? Let M, Abby, is equal to what? X raised to the power 1 over 3. Is that clear? So here we now say that M squared, Abby, minus 5M plus 6 is equal to what? 0. Abby? Now that we have that, so we can see what we have now look or sound quadratic, Abby. So of the various methods we have, so use the one you know best in this area. Remember, they are not testing quadratic equation here. What they are testing is you being able to get the value of what? M. Into over use module ni kó o lò. Tó bá jẹ́ almighty formula ló mọ̀ dáadáa, come and use it. If you know factorization method, come and use it. But the only benefit of using factorization method is that what? It is faster. Because 2-3 steps, we are done. Unlike the almighty formula that the method, the steps is long. Aside from being long, you still have to punch calculator into whereby you have a complex numbers. Hope it is clear. So let's use factorization method to make it fast as we have limited time. Now 1 times 6 is 6. What factor of 6 can give you minus 5? We can use 2 times 3, Abby. Minus 2 minus 3 can give us minus 5. Is that clear? Don't worry, we are getting to that topic very soon. So we now have M squared minus 2M minus 3M plus 6. Okay, is equal to what? 0. I want it to be there, no problem. So M into M minus 2 minus 3 into M minus 2 is 0. We can say M minus 2 into M minus 3 is what? 0. So it means M minus 2 is 0 or M minus 3 is what? 0. M here is 2 or M is equal to what? 3. But we are not asked to find M. This is the techniques ọgbọ́n tá a dá in order to be able to have solution to this thing, right? So at the moment we want to get X, you now go back to a real area where M was introduced into this solution. When do we introduce M? It happened in this place. Abby, you now say that, remember, there are many this thing you can use. Remember, recall, but do you get it? So in order to tell them this thing happened, this was the reason why M was part of our what? Of our solution. Can I continue? You now say that, remember, M, let me write it very well. M is equal to X raised to the power what? 1 over 3, Abby? Abby? Yes. So that now means, let me come to this place. That now means I can say that 2 is equal to what? 2 is equal to x raised to the power 1 over 3, or the other value we get is 3, abi, or 3 is equal to x raised to the power 1 over 3, right? Okay. Now, what do we do? You understand the concept, abi? Now, in this situation, base here is 2, base here is x, right? It's a little bit different from the first one we did, abi. When one of the two base is number and the other is a letter, the way we are going to approach it is, in this situation, we cannot force the base to be the same thing. Unlike the other one, we must force, if this is a number, this is a number, the only way to deal with that is what? We'll force those two bases to look alike. Is it clear? Now, but one is a letter, one is a number. It is not possible forcing a letter to becoming a what? A number. What do you now do? We rather work with the power. We also work with the power here. Abi? And the essence is, we want this 1 over 3 to disappear. How does 1 over 3 disappear here? We will simply take the inverse of it. In inverse, you just multiply it by, this is 1 over 3, its inverse is going to be 3 over 1. Is it clear? You do, okay, then what happened to this must happen to this, abi? So you can see it's like we introduce 3 to this x raised to the power 1 over 3, right? We also do the same thing, we introduce 3 to this 2. So this is the same principle we are going to use. We multiply this by 3 over 1, 3 over 1. This one will also be raised to power 3. Hope that is clear. Or you can write it as 3 over 1, no problem. Write it as 3 over 1. So clear. Worry about it, Daru. Oh yeah, let me see the area. Okay. This is the problem you're likely going to face. Because we have x in this side, abi. And the other time I introduced this concept to you, our x happened to be here. Here, lo shele. Oh yeah, jẹ́ kí n kọ́ bó ṣe like. Now, this is the same thing as x raised to the power 1 over 3 is equal to 2. Abi? So you are used to this, or let me space it. X raised to the power 1 over 3 is equal to 3. Is it clear? Ìgbà wo la máa ń lo orun tí mo fẹ́ lò yìí? Tí one of the base bá ti jẹ́ letter, tí kejì bá jẹ́ number. Ṣó ti clear? Nítorí pé eléyìí òkè letter lélẹ̀ number lélẹ̀ kò ṣeé ṣe kí n sọ méjèèjì di kí base wọn rí bákan náà, ìyẹn ò ṣeé ṣe. Is it clear? In that case, kí la máa ń yọ kúrò? Is it clear? Ó dàbí oúnjẹ ni. There are some food items. Bí ìgbàdo tán ti bọ̀. Do you get it? Wọ́n kàn ná sí ẹ. Do you still need to cook it before you eat it? Don't you prepare very well? What if it is ẹ̀wà? Tán ti sè náà gbé fún ẹ pé okay, oúnjẹ ta fẹ́ jẹ léni rẹ̀. How do you do that? Do you start eating it immediately? You undergo. So the processing are different. Ṣáàrin yẹn clear? So it's exactly what we are saying here. If one of the two bases is a letter, while the other is a number, in a situation yẹn, power la fẹ́ dì pẹ̀lú. But if first base is a number, second base is a number, base la fẹ́ dì pẹ̀lú. O gbọ́dọ̀ mọ̀ ta la ń deal pẹ̀lú. You, okay, mi fẹ́ lo only example kan mi fẹ́ lo example yẹn. Is it clear? Is it clear? So what do you do? We want to cancel, we want to remove this 1 over 3. How do you remove 1 over 3? Money, the way to removing it is to say times 3 over 1. But we are dealing with this one. Anything that happen to this must happen to this. Are you clear? Is it clear? So this one is also going to be raised to power 3 over 1. Because what happened there was that we introduced 3 over 1 to this. Same thing must also be introduced to this. Do you get that? So your friend just become a millionaire. What must happen? Ìwọ náà gbọ́dọ̀ gbóòórùn ẹ̀. Àbó ní gbóòórùn ẹ̀. Ó máa gbóòórùn ẹ̀ náà. tó bá dé jẹ́ pé gba lọ́rẹ́ ẹ fẹ́ jẹ náà nǹkan, your close friend, your tight friend, what will happen to you too? What will happen? Ìwọ náà máa bá gbádùn ẹ̀. Is it clear? Is it clear? So that's exactly what happened here. Oh yeah, the same thing is what we are going to do here. So cancel this 1/3. We multiply by 3/1. We say raised to power 3/1. In that case, 1 cancel 1, 3 cancel 3. Then 1 cancel 1, 3 cancel 3. So we are now left with x is equal to, what's the meaning of 3/1? Simply 3. 2 raised to power 3, Abi. Or we say x here is equal to 3 raised to power 3. It is not clear. Are you sure it is clear? So we now say that x is equal to 8 or x is equal to 9 or 9. Okay, x is equal to 27. So therefore, x is 8 or 27. Hope it is clear. So that's that. Now we now move over to the optional third assignment I gave to you. Who attempted that question? Do you attempt it? Let me see your. You don't do it. Good one. It seems these girls are more hardworking than the boys. I like that. All the girls except Islami, yeah. Even on my main assignment, do you do it? Let me see. Oh, where is it? Where is it? Man, where is it? Scope. Oh yeah, Oboski. All right, correction. Okay, sorry, the third question. Are we done copying this? Some are still writing. Let's wait for those ones. Oh yeah, Auntie Koriba. And that Drew. Educator. Islami uncle. Are you true? Aha. You only need to learn how those adjustments are done. Mm-hmm. 5 raised to power 2x plus 1 minus 26. 5 raised to power x plus 5 equals to 0. There is nothing new in this, Abby. All right. So you can see, can we apply law of indices directly? It's not possible for me to use indices direct. Why? Because in between my index numbers, what I have is not the usual sign. The usual sign should be either times or divide. In this situation, we have to get somewhere before what? We can apply our laws of what? Of indices. Now, what do? In that case, you concentrate on the index part of this question, Abi. This is an index number. This is an index number. Walaikum salam. Erama. So either this or this, Abi. But look at the power here and the power here. Which of the two is simpler? It will look simple. Will you see x ní power? Kí leléyìí? 2x plus 1. Now that means this is complex, Abi. We want to adjust this one to look something similar to this. Ẹ bá mi wò kí boys. What do you now do? Síbi ó ní 2x yẹn simple dáadáa, Abi. So we can write it as 5 raised to power x into 2. Do you get that? Do you get that? Now, how do we deal with plus 1? plus 1, Abi. So once it's, because of this plus 1, it has here, right? Remember, basically in indices, what changes to plus? Times. Because we have plus here, once this thing contain extra term, tó bá ti contain extra term, sign yìí will determine what we want to do. If this sign is plus, so we are going to say times. If it is minus, we are going to say that what? Divide. So in this case, I'm going to say times. Are you sure? Are you with me? 5 raised to power 1. Remember, we are dealing with the index term, Abi. What are the index terms? That is, we are dealing with the term containing index number. And what do when we say index number, kí ló ń jẹ́ index number? Index number has 2 components. It has base, okay. It has base and what? Tó bá sọ fún ẹ pé index number, kí ló ń jẹ́ index number? Number tó ní eyín méjì ló ń jẹ́ bẹ́ẹ̀. Eyín mélòó mo pè? Eyín méjì. Ìkan nínú eyín ẹ̀ là ń pè ní kíni? Base. What do we call the other one? Power. Is it clear? Is it clear? Right. So when we have extra term like this, right? If it is plus, changes to times. Is it clear? So this one, to want it to be written in index form, so it now has to be 5 raised to power what? 5 raised to power 1. I hope that is clear. I hope it is clear. Rọ́dí ó ti dàrú. Oye. Kọ̀ríbánkọ́. Are you sure? All right. So we can now say minus 26 into 5 raised to power x plus 5 is equal to what? 0. Abi? Now, the decision I want to create is, I want this 5 raised to power x to appear in many places so that I can give it a name. Right? So we now say that let q is equal to what? 5 raised to power what? X. Can I continue? Now, so what is 5 raised to power x? Q now. We now say q squared times 5. And what's the meaning of 5 raised to power 1? 5. Minus 26q plus 5 is equal to what? 0. Right? Now, this means 5q squared, Abi, minus 26q plus 5 is equal to what? 0. Is it clear? From here, we can apply factorization method you like most. Is it clear? But as for me, I would prefer the what? The almighty, the factorization method. Or you can use your almighty formula. We will get the same results. That was the reason you were taught. Can I continue? Yes. So we say 5 times 5, 25. What factor of 25 can give you 26? Factor of 25 we have is 5 times 5 can give 25. 25 times 1 can give 25. Which of these two can we adjust to become 26? Can I combine 5 and either by adding or by subtracting to get 26? You know it's only 25 and 1, Abi. So where's Ablaki? Oh, should come and help us do this. How can I do this and this to get minus 26? So definitely this will have minus, this will have minus. Is that clear? So that now becomes 5q squared minus 25q minus minus 1q, Abi, or we call it minus q. Do you get it? Don't bother yourself. So since I've not taught you this method, so I'm doing this one for time management sake. Use your own almighty formula. You will get the same answer. When we get to this topic, I will explain to you very well. So just look at what I'm doing. Minus q plus 5 is equal to 0. The fact that I don't know this method yet is not a problem. I've already taught you a method you can use. Use it. When you get to this area, go and use the almighty formula. Do you get it? So don't let this one now discourage you that I don't know it again. You know it. You are a mathematician. Do you get that? All right. So to do this area, it's going to be 5q into q minus 5. Is it clear? I don't want to bother you with this area. Then minus 1 into q minus 5 is equal to 0. The reason why I don't want to bother you with this is you know an alternative method. Is it clear? And I don't want to be explaining factorization in this thing. Is it clear? Use the one you know already. As soon as we get to the topic, we are going to do it. So we now say that 5q minus 1 into q minus 5 is equal to what? 0. Abi? That means 5q minus 1 is equal to 0, or q minus 5 is equal to what? 0. Is that clear? Now, I can now see that so I can now say that 5q is equal to 1. Abi? You know, when this one gets here, it changes to plus, Abi. 1 plus 0 is 1. Can I continue? Then here we say or q is equal to 5. Right? Now to get q, what do? Divide both sides by 5. We've already gotten q here. This cancel this, Abi. Q is equal to 1 over 5, or q is equal to 5. But initially we have to find what? X, not q. Definitely, how does q get into this solution? Go and trace it. Trace your step from here. Continue tracing it until you get to the area where q. Initially, q is not here. Q is not here. It is at this junction. Q was introduced, Abi. You now have to remind us that. Remember, or you can also say recall. Recall that what? Q is equal to 5 raised to power x. Can I continue? Now, we now say, now let's cultivate one habit of having the one, what we are looking for first before number. That was the reason why my sister was disturbed the other time. I can write it as 5 raised by x is 1 over 5. Is that clear? Or 5 raised by x is equal to 5. Right? So indices can now, what you know under indices can now be used. Is it clear? Now, you can see, we don't want fraction. When dealing with your indices, right? When you see a fraction, change that fraction back into what? An index form. You can see this is not in index. You can see this is not in index form, Abi. So once it is not in index form, change it to index form. How do you write 1 over 5 in index form? Wow. We say 5 raised by x is 5 raised by minus 1. Is there anyone who doesn't know how we transform 1 over 5 to 5 raised by minus 1? So we now say, or we don't have problem here. Though it is not yet in index form, Abi. Its own index form will be what? 5 raised to power, or 5 raised to power 0. Okay, 5 raised to power 1. Then what do you now do? You can see the base here is 5, the base here is 5. Right? Once the base is the same, they will cancel out. Remember, related to the first question I treated, I said this base must look perfectly like this. If a sign differentiate this one from this one, we will not just concentrate on it again. Is it clear? Then this 5 cancel this 5. We now say that x is equal to minus 1, or x is equal to what? 1. Therefore, x is minus 1 or 1. You can see it's very simple, Abi. Very, very simple. What you don't do, you said you got it. How come? How come? Okay, no problem. That shows you are a scholar. Abi? Scholar Khalil. I know him. I know this boy. Okay, I understand. To show he's a scholar, he used Q rather than our own K, you see? Yes, so that's it. All right, let me give you a class work. Tomorrow we are having a test, not exam, test. Test. But that one will be written on the board. I will write your test on the board. All right, I like this one too. 2 raised to power 2x plus 2 raised to power x plus 1 minus 8 is equal to 0. Come and try this. In just 3 minutes, you should be able to do it.